All right, second part of this review, number 7 and 8. These would be 6-point region questions. So these are a little more difficult. So we have a diagram below. We have a wire attached to the top of a tower, and we have a couple angles, and we know this point is 100 feet from the end of the wire. We want to find the height of the tower. So this is what we want. We'll call that x. All right. Now, you can see the big difference between this and the problem above is we don't have a full side here. So the question above, we had the entire side length right here. Looking at number 7, we only have a piece of this side. All right, so when this happens, when we only have a piece of one side, this is where we're going to need actually two variables. Because if you think about drawing our triangles again, which is always where I would start with these, I'll draw the bigger triangle with the 32-degree angle, and we know this is x. And then we have kind of our smaller, wider triangle right here with a 65-degree angle, with this side also being x. So we had a test on this, and what I saw a lot of people do is they saw this 100, and they just put the 100 here. But you can see that 100 doesn't represent the entire side. It's only a piece of it. So we can't just put that 100 there. It'd be nice, but it doesn't work at that point. All right, I should also probably mark our right angles in here and here. So what we can do to get around this problem is we're going to introduce another variable. I'm going to call that side y. Now we have some things we can set up. So I have the x's on this side of the triangle. Now if you look carefully, the 65-degree triangle, that's just a y. And this entire side we can call 100 plus y. All right? And that's how we'll label this side. We can't just call it 100, but we can call it 100 plus y. All right, now what I want you to do is set up your equations. So using these triangles, I want you to set up two separate problems based on those reference angles. All right, and then I will show you what I have in a second. So let's split off a little bit. We'll set up our two equations, and then we'll regroup to see what we can do from there. Okay, so we have two separate equations to work with. The larger 32-degree triangle, we have this equation right here, and the smaller 65-degree triangle, we have this equation here. So remember, if you don't have one full side when we redraw our triangles, that's when you want to have another variable involved. Now we can do what we usually do, and we'll cross multiply. So we'll do the same thing with both sides, and now we have x equals, and this is where you have to be careful. We have to remember to distribute, or to, I guess, keep that as one big term, the 100 plus y. So what we have is that x equals the tangent of 32 there we go, the tangent of 32 times the whole quantity 100 plus y. So the tangent of 32 times that whole thing 100 plus y. Now we'll go to the other side, bring this little squiggly line down a little farther. We cross multiply, and we get again x equals, and in this case it's just y times the tangent of 65. So that one's a little easier to work with. All right, so now you think back to last year, we actually have a system of equations now. So on this side of our line, we have x equals this stuff. On the other side of our line, we have x equals this stuff. So what we can do now, since x is equal to two different things, we can actually set those two different things equal to each other, right? X is the same as tangent of 32 times 100 plus y. X is also the same as y times the tangent of 65. Those are equivalent terms. So to solve this problem, we're just going to take these two x's and do some substitution. We're basically going to set them equal to each other. All right, so this is a lot of work. It's a long process, but if we just take it one step at a time, you guys can do this. So I don't want you giving up and saying, this is too hard for me. So just walk through it with me step by step. So we're going to take this stuff here. So we have the tangent of 32 times 100 plus y equals y times the tangent of 65. So now you can see we have one equation. It has all y's in it, and now we can solve. So in your calculator, and like I said, I'm not going to take that weird one out, but you can go into your calculator and just type in the tangent of 32. So I will tell you the tangent of 32 comes out to be about 0.624869, and then we still have our 100 plus y equals, and we go tangent of 65 in our calculator, and the tangent of 65 is about 2.1. This is not behaving today. 2.1445069 something along that. Remember, we don't want to round too soon, times y. And there's some decimals. It's a little messy. There's some distributing to do, but we're just going to solve this like you've solved every equation you've ever done in math. So first thing we're going to do is we're going to take this number and we're going to distribute it through to the 100 and through to the y. So what this comes out to be is 0.624869 times 100. We go to our calculator and it comes out as 62.4869. And then we take this number and we distribute it to the y. So it's plus 0.624869 times y. All right, so not a lot of math to do there, but just gotta be careful. And on the other side, we still have the same stuff. We still have 2.144. Geez, sorry about that, guys. There we go. 2.1445069 All right. Now this is something we can handle pretty easily. All we have to do to get the y by itself is subtract this term from both sides. So we'll subtract 0.624869y from this side. So those cancel out, we know that. We'll subtract the same thing, minus 0.624869 from this side. And I know I'm running out of room. Maybe I will slide this down a little bit. So I know it's getting a little messy. Where's my cursor? There it is. Let's try that again. All right. So what we have left after we do our subtraction is on the left-hand side, we just have our 62.4869. And on the right-hand side, after we do this math in our calculator, we are left with 1.519637757y. Again, notice how I'm not rounding too early. You know, all we have to do to get this y by itself is divide by this stuff. We'll just divide by this. This is just like if it was 2y, right? We'll just divide by 2. In this case, it's just 1.5, all this, you know, all these decimals. But we're still just solving for y. And I don't want to put that y there. I don't know why I wrote that. We're just dividing by what the y is attached to. So we'll divide by that number on both sides. 1.51963.757. So those go away. We put this into our calculator, and I will tell you, after all that work, we will get y equals 41. There's my number, 41.11963. All right, obviously you're going to be doing this in your calculator. I did the numbers already, but that's where I got my y value. Okay, so looking back at my original picture, the y value is this right here, this number right here. So we're not solving for y. We need to find x. So all we need to do is find a good equation, now that we know what y is, to plug back in and it will tell us the x. So how about this one right here? This equation right there. X equals y times the tangent of 65. So you remember last year in Algebra 1 when you would solve a system of equations, you would find one value and you'd plug it back in to find the other. So now that we know what y is, we can take that y and we'll plug it in right here. So we know x equals y times the tangent of 65. We're just going to plug in that number for y. So we have x equals 41.11963 times the tangent of 65. So, of course, you go into your calculator, you type those values in, and we're trying to find the tower of the nearest foot, and we get x equals, after we put all that stuff in, we get x equals 88 feet. So a big, tough question. We'll definitely look at some of these on our regents, but try the next one out. I will tell you the answer to number 8, once you work through it, is 40.9807, and it says to the nearest foot, so it'll be about 41 feet if you work down and you want to try number 8 out. So the answer to number 8, about 41 feet. So these are tough. Set up 2 triangles, use a system of equations, and that will help for these 6-point questions. All right, so good luck with that number 8. Call me over if you need help, and we'll keep on going with these.